Okay, so let's take a look at another rule of differentiation. This is something called the product rule. So you would utilize the product rule when you actually get a function which is the product of two or more functions. Okay, so if p of x is equal to two terms or two functions, f of x times g of x, then the derivative of that function p of x, p prime of x, and I'm using Lagrange's notation to demonstrate that, is equal to f prime of x times g of x plus g prime of x times f of x. So you do the derivative of one of them times the other plus the derivative of the other times the other guy. Okay? And you can also express this using Leibniz's notation, right? So you do derivative, right? The derivative modifier, derivative of a function with respect to x, right? So you do derivative of g of x times f of x plus g of x times the derivative of f of x. Okay. Either way, both will mean the same thing, right? So we'll just use a combination of the two. I tend to use the derivative modifier, d dx, or the rate of change with respect to x, right? Because it just kind of clearly shows that we're finding the derivative of something. It's my derivative modifier. Okay, so this is just a great way to kind of just show your work. So I'm going to just show you guys an example really quickly. Let's say we wanted to differentiate this equation of g of x. If we want to find g prime of x, if we're using the product rule, I'm going to do the derivative of the left factor. I'm going to clearly state this by using the derivative modifier, x squared plus 2 times the right factor, 4x minus 5, plus the left factor, x squared plus 2, times the derivative of the right factor, 4x minus 5. So you can kind of note that I'm using a combination of Lagrange's notation as well as Leibniz's notation. Really means the same thing, right? But it's a great way to kind of just show your work. So the derivative of x squared plus 2 is 2x times 4x minus 5 plus x squared plus 2 times the derivative of 4x minus 5, which is basically 4. And this is your derivative function, g prime of x, and then I'm just going to expand this guy out. So you get 8x squared minus 10x plus 4x squared plus 8. And this is g prime of x. Right, and then you can just kind of collect the like terms. So g prime of x here is equal to 8x squared plus 4x squared minus 10x plus 8. In this case, you get 12x squared minus 10x plus 8. And that's basically your derivative function. Okay?